Okay, so last time we took some notes and we did some good quality work and we looked at our chart here. There was a lot of ifs and thens and nots and logical equivalency and it was lots of fun. So let's practice and see if this makes sense. So I'm gonna put some problems up here. I'm gonna trust that you're gonna pause and at least try them on your own. So grab a notebook and give them an attempt, and then unpause it, and then check your answers. Okay? So our first set here, identify, hypothesis, and conclusion. Remember, if we have an if then statement, so if, let's rewrite this. So if, remember we use P and Q, so if P, then Q. And our hypothesis is P. It's the first part. It's what we assume. So if this is true, then our conclusion is true. So Q is our conclusion. Alright? So this is just a way of looking at it, because they're not always going to use if and then. Okay, so if a person at least 16 years old, then the person can drive a car. Well, this one is an if then. So our hypothesis is a person at least 16 years old. And our conclusion is that person can drive a car. Okay, nice and easy. Our next one, figure is a parallelogram if it is a rectangle. So this one tries to be fancy and it switches the order around. So if it is a rectangle, then it is a parallelogram. Yay. I feel like an English teacher underlining parts of a sentence. It's so cute. Okay. The statement A minus B is less than A implies that A is a positive number. So implies is another fancy way of making our little arrow. So this statement, that's our if. So if this, then that. Or then over here. So our hypothesis here is that A minus B is less than A. And if that is true, then B is your positive number, so that is our conclusion. Alright, that's not so bad. So hypothesis first part, conclusion second. Alright, let's do some actual work here. So write the conditional statement for each of the following. So first one, 16-year-olds or 18-year-olds are eligible to vote. So how can I write this? So if you are 18, then I was gonna write then again. Then you can vote. Still feel like an English teacher. Look at me writing sentences with proper punctuation. Haha. Alright. Next one. A squared is less or over B is less than A over B when 0 is less than A less than B. Okay, so this one's a little bit different. So we say when this happens, we end up with this result. So really we have one of those sort of, it's written backwards. So this part has to be true before this can happen. So that means this is going to be our hypothesis. So, and we'll do 7 in green. So if A is between 0 and B, then this other side, A over B squared is less than A over B. I'd like to see an English teacher write a sentence as quality as that. Don't think they can. Alright, and number 8 is our little Venn diagram. Remember, the if is the more specific statement, and then the then becomes the more general. So this part in the smaller circle, or oval, has to be our hypothesis. So if we have a rotation, so if that specific case is true, then it is a transformation. Okay, dot. So if the smaller one is true, then the bigger one is true. Because this wouldn't work the other way around, because we say if it's a transformation, is it going to be a rotation? Not necessarily. It could be a reflection, or translation, or dilation. And all those would also fit in this bigger transformation oval. So we have to start with the more specific one. Okay, so if rotation, then a translation, or transformation. Alright, that's that. Next one, determine if it is true, if false, give a counterexample. Alright, counterexamples. So if 3 points form the vertices of a triangle, then they lie in the same plane. Again, here's that word plane, which makes me regret the fact that we don't start with chapter 1 where they explain how points on a plane work. So you're going to have to sort of trust me on this one. Imagine, if you would, remember we said, I can actually draw this. Let's draw a rectangle. Our plane is just a two-dimensional surface that extends forever. Okay? So what they're saying is, if you have 3 points, and they form a triangle, are these all on the same plane? The answer is always going to be yes. And we're going to get into this when we talk about lines and planes, but the key point here is if, wait, I don't want to say if, 3 points will always be on the same plane. And we're going to talk more when we get into three-dimensional shapes, but it's an extension of if you have a line. So if we have 2 points, no matter where we draw those 2 points, they will always connect and they'll always make one line. So 2 points will always be on one line, and 3 points will always be on one plane. And then we'll talk about what happens if we have a 4th point much later on. Okay? And it's going to be lots of fun. Lots of fun. He's got glasses. Okay. So this is true. Or capital T if you're feeling lazy. Alright, let's get rid of this. And this one too. Alright, so this one is true. Next one. If x is greater than y, then the absolute value of x is greater than the absolute value of y. So no doubt, some of the time this is going to be true. If we put in just some regular old numbers, if we say 5 is greater than 4, then is the absolute value of 5 greater than the absolute value of 4? And you say, yeah, duh. Okay? But really, this isn't every example. And really what we're looking for is we're looking for one that doesn't work. That's what we're trying to find. We're trying to make this statement look stupid, right? It's dumb. So you got to think, well, it's absolute values. Think what's special about absolute values? And that means it takes negative values and makes them positive. So what if we put in some negative numbers here? So let's say, what if x is still 5? And let's say y is, I don't know, -6. So then we would say, then is the absolute value of 5 greater than the absolute value of -6? Well, this would be 5, and this would be 6. And is 5 greater than 6? No. So this proves that this is false. And if it doesn't work one time, it gets to be false all the time. Alright, so that's it. False. Find one counterexample, and you're done. Alright. And our last one. This one's a little trickier. Maybe, depending on your reading skills. So if it's springtime, then the month is March. Alright? And I looked this up. March is indeed part of spring. March is in the spring. So is this statement true? The answer is no, it's not. Even though March is part of the springtime, if we think back to our Venn diagram here, the way this would be written is that spring would be down here. This would be our specific case, and March would be our general case. Does this make sense? Is the entirety of the season of spring contained in March? No. Spring's like March and April and some of June, I think. In May. I missed the month. In May. So this actually is written backwards. What would make this true is if we said, hey, play nice. Oh, they're all together. We would have to switch the order on. We'd have to say, if the month is March, then the season is spring. And that would be an absolutely true statement. But to say that if it's spring, it has to be March, that's incorrect. Because we can say, what about April? That's our counterexamples. Easy as that. Okay? So, yeah, there we go. True, false. And our last section, last one actually. Write the converse, inverse, contrapositive of the following conditional statement. Find the truth value of each. So you might need to look back to your notes and remember that our conditional statement, conditional, means if P, then Q. So then our converse, actually, well, that's weird. Let's start with the inverse. So our inverse is when our values are flipped around. So instead of saying if P then Q, we say if not P then not Q. Right? And then our converse, I don't know why I switched the order around. It's kind of dumb. Our converse is when we keep these statements the way they are, but we flip the order around. So instead of saying P then Q, we say Q then P. So if Q then P. And our last one, our contrapositive, our extra long word of the day. What that is our, we take our inverse and then we flip that order around. So instead of saying if not P, then not Q, we say if not Q, then not P. Right? So there's a lot of purple. So we start with our conditional statement. Bree drives exactly 30 miles an hour. So if she's going 30 miles per hour, then she goes 10 miles in 20 minutes. All right. And then let's see, hold on. So we'd say if she's going 30 miles per hour, you think 20 minutes, that's a third of an hour, so you take 10 miles times 3, so that's 30 miles in 1 hour. So this rate checks out. So this conditional statement is true. Right? So if you're going 30 miles per hour exactly, right, then you'd go 10 miles in 20 minutes. So how about our inverse? So if you say, instead of if 30 miles per hour, so if she's not going 30 miles per hour, then she does not go 10 miles in 20 minutes. And I didn't give myself enough room. Okay? So what do we think about? So this one's a little tricky in the way you have to think about it, and that we're looking for it to be true or false, we need one example where that's not the case. And we could spend all day making tables about how fast she goes, how far she's gone. But what we're saying is if she goes at any speed other than 30 miles per hour, is it possible for her to drive 10 miles in 20 minutes? And so we can think of sort of a ludicrous example here. Let's say she goes really fast, right? In the first minute. So she goes all 10 miles in 1 minute, right? And then just stops. So she definitely wouldn't be going 30 miles per hour, right? So this part's right. But it's saying it's impossible for her to go this distance, which is not true. We can go. Wait, am I saying this right? Hold on, I'm freak. No, that's right. So if she's going any speed other than this, she can still manage this rate, which means this statement here is false, right? Because without going the speed, you can still manage to go 10 miles in 20 minutes just by changing speeds some of the time, okay? And then we take our converse, which is our next one. So we flip the order around. So if we say if she goes 10 miles in 20 minutes, then she's going exactly 30 miles per hour. And remember we talked about logical equivalence and how inverse and converse are saying essentially the same thing. So we can use the same logic that I sort of badly explained up here to explain why this one will be false as well. So if we think about it, if she goes 10 miles in 20 minutes, does that mean she necessarily had to go 30 miles per hour exactly? And the answer is no. There's any number of ways you can get to 10 miles in 20 minutes without going 30 miles per hour the whole time. So this is also going to be false because we can come up with any number of examples where this doesn't work. Okay? And then our last one, our contrapositive, which gets a little crazy. So we take our nots and then we flip the order. So if not Q, so if she does not go 10 miles in 20 minutes, so she goes some other distance in some other time, then she was not going exactly 30 miles per hour. And so this is actually going to work out to be true. Because remember we said, again, logical equivalence, the conditional and the contrapositive will have the same value. And if we think about this, if she doesn't go, if she goes anything other than 10 miles in 20 minutes, would it be possible for her to go exactly 30 miles per hour? No, because if she was going 30 miles per hour exactly, then she would have to go, wait, did I put 10 inches? Why did I put 10 inches? 10 miles in 20 minutes. So if she's going exactly the speed, she has to go this far in this much time. So if this is not true, then this can't be true. And if they're both not true, then the whole statement, through the wonder that is math, makes this true. Okay? So this doesn't work, then this doesn't work, so it's true. And hopefully you're plenty confused and ready to do some practice on your own. So I will leave you to that. I'll put links down in the comments over here. You're going to hit your subscribe button over, I don't know what a subscribe button is. It's somewhere. Hold on. Oh no, the subscribe button is kind of like over here-ish. This is where you can see my awesome view count. It's going to be like 1,000,000. That's 100,000. Whoops, there's another zero in there. And it's got like all these thumb pluses. 10,000. And it's got one unhappy thumb, right? There's always some jerk who's like, oh, I don't like this. We're not going to worry about that. So, subscribe, look at my view count, go watch some other videos. Yeah, videos are fun, and then have a good evening. All right, good night. Like, comment, subscribe.